If we're going to find the derivative using the quotient rule, it would help to see this function as a quotient. Remember from trigonometry that secant is the reciprocal of cosine, that we could express it as 1 divided by the cosine. Now we've got a quotient. If we want to use the quotient rule, well, we could use that version with a and b, that we've got the derivative, just the factor from the denominator times the derivative of the numerator. Take away, leave the numerator as it is, differentiate the denominator all over b squared. It does help to go ahead and say that a is going to be just 1 and that b is going to be the cosine of x. Let's get right to it. So that is that the derivative of the function will be the cosine of x times the derivative of 1, which is 0. Take away, leave that first factor as a 1, differentiate cosine, that's the opposite of sine, and this is all divided by cosine squared. Okay, well, we know that anything times 0 is 0. A double negative turns out positive. This is all over that trig function squared. So we've got sine of an angle divided by the cosine of the angle squared. Now we can clean this up a little bit. That's the same as 1 times sine in the numerator. In the denominator we've got cosine of x times the cosine of x. Say it again. That's 1 times the sine of the angle in the numerator, cosine of the angle times cosine of the angle. We could say that that's the same as the secant, since 1 over cosine is the secant, times the tangent, since sine over cosine is the same thing as the tangent. In this way, the derivative of secant is secant x tangent x. And we have found that derivative using the quotient rule.